So in this video, let us solve problems based on relationship between zeros and coefficients of quadratic polynomial. And we've got a problem here which says find the zeros of the quadratic polynomial x squared plus 7x plus 12 and verify the relationship between the zeros and its coefficient. So we've got this quadratic equation x squared plus 7x plus 12. We need to find the zeros of this. That is, we need to find the values of x such that when you substitute those values of x in this equation, you get 0. So what you have to do is you just have to split it or factorize it. So that's what you have to do. So you factorize by splitting the middle term, which we've done lots of times in the previous videos. So if you want more details about it, so please do check out the previous videos in which we factorize the quadratic equations on the chapter titled Factorization. So here the coefficient of x squared is 1, so 1 times 12 is just 12. So therefore x squared, factorizing 12, you need to, the factors should be added or subtracted to get the middle numbers. So 4 times 3 is 12, 4 plus 3 is also 7. So therefore x squared plus 4x plus 3x plus 12. Let me repeat. The splitting is done in such a way that when you multiply the numbers, you get this term, 12. So now, grouping this, you can factorize, taking out x here, you have x plus 4. And here also you need to get x plus 4. So to get x plus 4, you take out 3 here. So considering this, you can see that considering these two terms, you've got x plus 4 common. So taking out x plus 4, you have x plus 3. So the factors are x plus 3. So you need to get the zeros, right? So equate this to 0. So x equals minus 4 or x equals minus 3. Equate this separately to 0 and this separately to 0 and you get this. So these are the zeros of the given quadratic equation. So let this be alpha and beta. So now let us verify the relationship between the zeros and the coefficients. So the first relationship that we have, the sum of the zeros. Sum of the zeros equal to minus b by a, right? So the sum of the zeros is nothing but alpha plus beta should be equal to minus b by a. Let's see what is alpha plus beta. Alpha plus beta is minus 4 minus 3, which is equal to minus 7. Let's see what is minus b by a. Minus b by a is minus b is minus 7 and by a is 1. So this is also minus 7. So minus 7 equals minus 7. Therefore, this is verified. The sum of the zeros is definitely equal to minus b by a. So now the next verification is the product of the zeros is equal to c by a. So that is alpha beta should be equal to c by a. Alpha beta is nothing but minus 4 times minus 3 equal to c by a. C is 12 by a is 1. So 12 by 1. So minus 4 times minus 3 is plus 12. So 12 equals 12. Therefore, it is verified. So that's all. It's a pretty straightforward and simple problem. All that we had to do was find the zeros, which we did, and then verify it. Sum of the zeros should be equal to minus b by a, and product of zeros should be equal to this. If it's not, do tell that on verifying the relationship between the zeros and its coefficients of the given quadratic equation, it is found that they are not equal to each other. So before we end this video, this problem is done. Before we end this video, let's quickly solve another problem on the similar concept. Alright, here we have another problem which reads like this. Find the zeros of the polynomial f of u, that is function of u equals 4u squared plus 8u, and verify the relationship between the zeros and its coefficients. So we've got a quadratic equation here which is 4u squared plus 8u. So we need to find the zeros of this. Right? Before we can verify the relationship between the zeros and its coefficients, we have to find the zeros for which we have to factorize. So taking 4u common, you can see that both the terms have got 4u, we get u plus 2. So since we have to find the zeros, we need to equate this to zeros and find the values of the unknown, that is u. So 4u equal to 0 and u plus 2 equal to 0. So this will be equal to u will be equal to 0. So 0 is one of the 0 and u equals to minus 2 is another 0. So the zeros of this given quadratic polynomial are 0 and minus 2. So u equal to 0 or u equals to minus 2. So hence alpha equals 0 and beta equals minus 2. So now let us verify the relationship between the zeros and its coefficient. First one is sum of the zeros. Sum of the zeros should be equal to minus b by a. So first let us find the sum of the zeros. Sum of the zeros equals alpha plus beta, which is equal to 0 plus of minus 2, which is equal to minus 2. Now let us verify minus b by a. Minus b is, in this case, you see 4u square plus 8u is nothing but ax square plus bx plus c equal to 0, where c is 0 here. So we do not have a c, so we only have a and b. B is 8, so it's minus 8 by a is 4, which is equal to minus 2. So therefore this is matching, so this relationship is verified. The sum of the zeros is indeed equal to minus b by a. So the next thing that we have to verify is the product of the zeros. The product of the zeros is equal to c by a. So the product of the zeros is nothing but alpha into beta. Since alpha is 0, 0 times minus 2 will be equal to 0. And c by a will be equal to 0 by 4, which is also equal to 0. So therefore, since these are matching, the relationship between the zeros and its coefficient, that is another one, the product of the zeros should be equal to c by a, is also verified. So another very simple concept and a very simple problem based on the simple concept. So this ends this problem as well as this video. All you have to do to solve this problem is remember the relationship between the zeros and the coefficients. Those are two of them. Sum of the zeros equals minus b by a and product of the zeros equals c by a. And this is specifically for quadratic polynomials. So I'll see you in the forthcoming videos with more problems based on the relationship between zeros and the coefficients of quadratic polynomials.